Welcome back. Usually we're not going to know what has to go into the array. We're actually going to be populating that dynamically. But sometimes you know at compile time that you want to stick items into an array. This leads us to the ability to create something called an array literal. Once you declare it, it can't be changed in size, and you're literally just telling the array at declaration time, these are the values in this position. So I'm making an array of integer called numbers, and numbers equals curly brace, position 0, position 1, position 2, position 3, close curly brace, done. This array is always going to hold a maximum of 4, and we can reassign the values, but we can't add any more values to it beyond, or we can't add more values to be stored. It's always going to hold only 4. You can only do literals at the declaration level, and sort of another way to initialize an array, this would be it's already been declared, but now you're using the new operator. Instead of specifying the size, you say it's a new array, and these are the values that go into it. And again, it's going to have these 4 values. Just know that you might run across those as alternates, but it's a very, very narrow use case. So if this, seems a little syntactically weird, you can look it up when you need to. It's definitely not something that I worry about or that I've actually used more than a handful times in like a 25-year career. It might just be the types of problems that I'm solving. But anyway, arrays do support this. Another thing to keep in mind about arrays is arrays will be able to report back how many items, not how many items are currently stored, but the maximum number of items that can be stored. So, for example, if you declare the hour array to be size 24, but you've only stored 1 hour, its length is still going to be 24. So array lists have a size method. Array objects have a length property. Notice, no parentheses. Okay? It can't be changed. It's immutable once the object has been created, so we can just use the .length property when we need to get information about the length of the array. And this leads us back to that for loop. Because the length property can be reported back and we know the fixed bounds of the array, the for loop is our friend. So we saw the for statement used with for each, very useful for array lists, but a for loop where we need an index value, as we saw in the previous video, is also another way to use that. The general form, just once again, for this code gets done in initialization, semicolon, this is our condition, semicolon, this gets done at the end of the loop. Then what are we going to do? A for loop can be written as a while loop. Before the while, we do our initialization, while some condition is true, what are we doing? And then before we come back up, do our post body action down there. Okay, so the for loop is just like a really, really specialized while loop in some ways, with a different syntax. But the idea being the same kind of work can be done. So if we want to count, or if we want to process the information in an array, starting at position 0, as long as that position is less than the length, do something, and then change the position. It can also be done in a while loop, starting at position 0, as long as the position is less than the length, do something, and then change the position. So you will find uses for the for loop outside of arrays, but here's where we're introducing it, and you're going to get a chance to practice it in this lab. So do take the time to get comfortable with them if you're not yet comfortable with them, and do take time to get comfortable with array syntax as well. Shifting gears to the Java array object, there are several methods in different objects that are useful for array processing. So the system object has a method called arrayCopy, and it's a static method, so the way you would use that is system.arrayCopy, and then we could take one value of an array and put that into the set of values in another array. It creates a completely separate set of memory with the same values in it. Effectively, it's creating a second array and saying take position 0 and make another copy in position 0 of the other array. Now move over to position 1, take what's in position 1 in our source array and copy it to position 1 of our destination array. Move over, take what's in position 2 of our source array, put it into the position 2 of the destination array. The other things that are useful is arrays are often sorted, and that we often need to start with all of the arrays in a certain state where they have a default value. And if the arrays are in sorted order, we can also do what's known as a binary search, where we cut the array in half and ask, is it in the first half of the array or in the second half of the array? And that makes it easier, faster to find an item. We'll take a look at binary search in a supplemental video and different search methods, but just know that the Java util arrays class have utility methods in order to be able to manipulate and work with arrays. These arrays methods are static, which means that the way you implement them would be arrays.fill, and then you're going to pass the array and then a value to fill the array with. Arrays.sort, and then choose the pass in the value of the array. And look at the Java API for the Java util arrays class in order to get the specifics of what the parameters are and what results come back from that. One last thing to keep in mind is that the ArrayList object has a method called toArray, which will take your array list and return an array of that object. So if you find that you might need to do some things that are more easily handled if the objects are in array form, your array list is happy to convert itself to make that possible. So, just a few more things for this video before we shift out of the weblog analyzer. Let's take a couple of moments to think about arrays. Pause the video at this point, well, after I tell you what to do. But if you had this list or this array in the variable numbers, could you write a for loop that would print out every item in this list? Think about what that would need to look like. Try it. And then declare the static array in a class in BlueJ and test it and see if you were successful. Welcome back. Another thing that you can do would be to populate an array with a sequence of values that are the result of some mathematical equation. One of the more famous mathematical sequences is the Fibonacci sequence, where the value in a location is determined as the sum of the two preceding values. So we define that the first position in the Fibonacci sequence has a value of 0, the second position has a value of 1, and then each subsequent position is the result of the two preceding values added together. 0 plus 1 is 1, so that becomes 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5, 3 plus 5 is 8, and so on. We find this sequence in many different patterns in nature. The patterns of lines on a nautilus shell, the pattern of seeds in the center of a sunflower, and so on. So it might be an interesting exercise to see if you could write a simple for loop that gives the first 25 values in the Fibonacci sequence. So pause the video and see if you can make that happen. Welcome back. Just a couple of other things to keep in mind with for loops. A for loop doesn't have to just add 1. So you don't have to just use for loops with arrays. Just like with a while loop, you could change your step value. You change your post loop action to some other operation, and in this case it will go ahead and take the previous value, add 3 to it, and then store it back in, and our loop will behave according to that post loop action. So while it is often the case that we want to go up by 1 or maybe down by 1, that is not the only thing that can go in that last section for the post loop action in the declaration of a for loop. Also, that means that we can do things with the for loop and an iterator. Pre-loop action, grab the iterator. What keeps us in the loop? The iterator has next, semicolon, nothing. No post body action required because an iterator will move through by calling the next inside of the body of the loop. So you can sometimes see for loops behaving in different ways by having this as an option. So these last several examples are good to know about, but you might not run across them for years. Just keep in mind that the for loop has a general structure that we try to maintain, and then we sometimes find ourselves using it in different ways. Let's see if we can tie up this first part. Arrays are a good choice if we know that the collection can't grow beyond a certain bounds. It is a fixed size. Arrays use square brackets. A common way to read the variable is the name of the variable sub the name of the variable in the box. So hourly counts sub hour. Makes it easier to communicate, and it indicates that you have more than one value stored in that array of hourly counts. Arrays require indices. That requires an index to get at a value. So for loops are a good choice because for loops can be used when an index variable is required. A for loop is, it performs a similar function to a while loop in that it asks the question at the top of the block of code, and for loops are sometimes easier to see what's happening when a known number of repetitions are known. And we tend to use for loops with a regular step size, although even that is open to being dependent upon which statement we put in the post body action. Okay? You've survived so far to this point. Take a break. When we come back, we're going to use arrays in a very different way, and you're going to want to have a sort of a fresh mindset when we go and look at the automaton project that comes for the latter portion of the chapter. Okay, talk to you soon.